Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 144. Please follow the live stream on LinkedIn. That really helps us get the word out, train the algorithm. Also, your reposts and comments also really help. Our guest today is Dimitri Druce, senior consultant at InnoQ. Welcome, Dimitri.
Welcome. Thank you for inviting me. It's a pleasure to be here.
So before we dive into OWASP authorization, authentication, microservices challenges, maybe you could just quickly introduce yourself. How'd you get here?
Actually, my name is already written there. I'm in the, I would say, security industry since almost 20 years. So I started with projects related to smart cards, HSMs, later PKI, and also trust execution environments, the global platform one. Later went over to a vendor related to actually, authentication. Maybe you heard the name of the company. It's Vasco. Nowadays it's OneSpan. And then I decided to
remember them well.
Yeah, and then I decided to actually quit the security space, and because I wanted to orient myself more in the relation of architecture, and went to InnoQ, which is a small consulting company. So we're around 150, 160 people in the entire DACH region, so Germany, Switzerland, and Austria. But since my knowledge from the past was somehow pretty required, all I do at InnoQ is also security, but from the other side. So in the past of building products.
My cat has knocked off one of my lights, so if you just give me 1 second.
Okay.
I said something new goes wrong in every episode, so there we have it. Sorry for the interruption. Go on.
Oh, fine.
So now you're at InnoQ, and maybe actually tell. Let's introduce the topic. So I found your articles to be very interesting, and I have to say, I'm just giving a little background for this topic. I always read the OWASP security recommendations for authentication and authorization, and I always think, oh man, I need to help these people and rewrite it. It's so old. The information they present is just so old. So I have to really thank you for undertaking to do that work, because I always say people who don't actually offer to help shouldn't get a chance to complain about it. So I never really actually did complain, because if I wanted to complain, I should just fix it. But at the same time, I can still be really happy that you actually took the time to redo it. So maybe tell us a little background, how did you come to that decision, and what was the process like?
Actually, the last step in that process was my talk at the OWASP AppSec EU conference in Barcelona this May, where I had a pretty big mouse and kind of challenging everything which is written in that particular cheat sheet, and showing the audience what is wrong, what is challenging, why it's problematic, and how it should be actually done. And then being back at home, I thought, okay, I cannot just criticize things. I have also to, like you just said, I also have to make it better, to put something in place. And that was actually the start of the series, which took me about 3 months to write, because you have to settle your ideas, your thoughts, etc. But if I go one step back, or actually multiple steps back, why have I given that talk at all? Being at InnoQ as a security architect, or working as a security architect, I'm always kind of struggling with specific perceptions of people in projects I meet. It's not always the case, but very often recommendations from OWASP, or even standards which might be obsolete, or obsolete not, but outdated, are perceived as kind of holy scripture, and it is then impossible to move something. So, and
the Gartner Magic Quadrant says this one's the best. What do you mean that it's not? It sounds a little bit like that, actually. Well, OWASP says these are the recommendations, and my ISO 27000 security requirements seem to agree. How could anything else not be true? Is that what you're saying?
You know Bill Burr? the guy who wrote those Nest password recommendations 20 years ago.
Yeah.
Oh, you heard about him, and he gave a public um, excuse after being retired that it was the biggest or the wrongest decision in his whole life. Yeah, and you know that that decision resulted in billions of loss in the industry because it is just wrong. Yeah, so
Yeah.
we're just all people, and we all do kind of errors, and we have to try to understand that and also to make the best out of it. So from that point of view, I don't want to say it's a problem. It's more a chance which we all should take and make the world just better.
So let's dive into the content a little bit. So I want to start actually with microservices, because this is the OWASP microservice security cheat sheet. We're not talking about mobile apps here, right? We're not talking. So I think it's important for that context of this conversation. And so maybe we could just start on microservice. How do you define microservice? How's a microservice different from, for example, an API?
A microservice is there are many definitions, let's say this way, and some of them are confusing. In my particular understanding of a microservice is more related to what people are also are naming self-contained systems. So that basically means you ship your code, including your particular API, so like UI elements, which might be combined to a bigger UI. It ships with its own database, but the entire service is responsible for a specific business domain part. Just do one thing and do it right in that from that point of view. This is what I understand under a microservice.
And so my understanding of microservices, and I'm not an expert here by any means, so forgive me if I'm wrong about this, but I always saw a focus on no external dependencies, so that we know that if we ask a microservice to do something, it's always going to be able to give us an answer because it's self-contained. Is that accurate, or is that a rule that can be broken?
It's a wish, yeah. It's something which is desired, but as a single microservice is performing a single business part, it pretty often needs information from other microservices. Yeah, and the question is, how is that information going to be available to that microservice? Yeah, there are different options to do so, and from the perspective of the Microsoft definition, you should do it asynchronously. Yeah, so it's about data replication, if you like, at that sense. But then you have an indirect dependency. You are depending not on a service during the runtime because you don't have to communicate to that directly anymore, but you depend on the data which comes from another microservice.
So
Does that make sense?
It does make sense, and it makes sense that it would be. I wonder how something could be many things can't be completely atomic. They really do need to call. But it sounds like what you're saying is that functionally it's a unit,
Yeah.
more than necessarily it's completely autonomous and without any dependencies. But it's sort of a functional, like, sort of loop around this process. Does that sound right?
Yeah, exactly.
Okay, good. We're done with microservice. It's funny because sometimes I go through the title and we're halfway through the episode and we're like, we just defined what we're talking about. I always think about authentication and authorization. First we identify principles, and then we figure out if we should allow this thing. So let's just start with the authentication of microservices first. What are the entities that that need to be authenticated?
It can be everything. Yeah, it can be an end user, it can be a system, it can be even a path a request took from the ultimate sender to the ultimate receiver, if you like. And then we have to find a way how to put all those, not to put, how to properly authenticate all those principles, and make that information available at the level where it is needed. Yeah, so it might be a microservice at the end, might be something else.
Yeah. And we hear a lot of talk about NHI, non-human identity. That's a whole new segment, I guess, of the market they're trying to say. Um, and um, and so, I always think of it as software. Like we have humans, and we have software, and we have more software than humans. So software could maybe be another microservice. A software could be um, um, an app running on a phone, or it could be I don't know, the IDP itself, let's say. So I just think of it as all software, and those software entities have identities.
Yeah,
For
exactly.
example, yeah, a mobile app or web page might have a client ID that identifies it. Um,
It can even, so if you go for trusted computing, you have also identifiers of the computing platform there. So things which are issued by the platform to particular workloads, which
hmm,
might be also a job or something like that, might be a certificate, doesn't matter.
yeah, and there are some of the components themselves might have identities. So, for example, a server that spools up might provide an attestation, which it then used to get a SPIFFE ID.
Yeah.
So it could be an attestation about the hardware, even if it's virtual hardware. There might be an attestation about it. Um, and the authenticators also have attestations. So some of the things and so one of the challenges that I think about with microservices is I think of them being like on the back end. Um, and so they don't have a connection to the actual human. And so microservices are passing tokens, I guess, between each other to represent a connection to a human. But what are your thoughts on? I didn't see a lot of talk in your cheat sheet about how you know which tokens should be trusted as you pass them downstream. Especially if there's no proof of possession involved.
Let me open my cheat sheet, the proper one, just a moment. So in principle, um, it's about which component is taking a role of to verify the particular token. Yeah, there are different components involved. It can be um, it can be the authorization server which issued the server the token. It could be, for example, the OCSP responder of a CA who issued a certificate. It's all about that definition. It is also all about the definition of what is meant by a token. Right? It can be a JOT, it can be a certificate, it can be a session, and then it's the question who issued that, who's taking care about that, and who's the trusted party, if you like, which I can trust or verify. And at the end, it comes down to your ultimative trustor in your system. So the PKA part, do you trust that key which has been used to sign this and or that?
Right. And actually, I'll give you a very practical example of this. And so when a mobile app authenticates a person,
Mm-hmm.
it might get back an ID token and an access token.
Mm-hmm.
And the ID token contains the audience of the mobile app because the mobile app authenticated the person. And so
Mm-hmm.
this ID token is issued to the mobile app. Um,
Exactly.
and so the question is when calling microservices via an API, does the mobile app present both the access token and the ID token? Or let's say maybe presents the access token in the headers and the ID token in the payload. But is
This
it
is
okay to pass the ID token, the identity assertion, to microservices, which are assuming these are first-party microservices? That's my question.
Yeah, so this is very important part, because if you differentiate between third-party and first-party services, so if that app belongs to a particular first-party application, so basically this is a front end of that application.
Right,
The question, the question is, why do you need an access token? Yeah, because if you take a look at the threat model of OpenID Connect, respectively O2, you will see that, everybody will see, you know that, all the access token, the client ID, client secret, they are only there because the third party is untrusted. So, and if the mobile app acts in the first party context, from my point of view, just pass the ID token downstream to your particular application. But this is a gray zone, if you like. So if you are for example, in a browser application, that would be the way to go, because otherwise you have kind of corset and you're always trying to escape it, because people are using access tokens as replacement for session management, and that hurts a lot.
Right. So I want to drill on this a little more. And I'm going to ask you, so you've been doing this for 20 years, so you have crossed paths with SAML assertions also. And so this is just a non sequitur question, but do you see people passing SAML assertions ever?
Not in the last 10 years.
For first party, third party, like?
SAML assertion, from my experience back then, is only for first party, because it was all about pure authentication and transferring of attributes required for authorization purposes. And same is also true for CAS, Central Authentication System. Nobody heard about that, almost nobody, if I talk about that. If you just compare CAS and O2, it looks like O2 is kind of an extension to CAS, because it's closed the gap which was there to address third party. Because you would like, so me as a person, I would.
You mean the Central Authentication System, the CAS protocol from in the 2000 aughts, let's say?
It's old. Yeah.
Yeah. But so let me push back a little bit, because I was just giving that example because I have actually seen it myself, where companies would say, we're in this case, we're passing the SAML assertion. I think it's okay in certain circumstances. But the ID token is very similar to the SAML assertion. You could say the ID token is just a JSON version of a SAML assertion. It has the details of the authentication event and optionally claims. But now let's say you have this ID token that's been issued to a certain mobile client. You've passed it downstream to microservices, and so the audience is potentially going to be different to the clients that are using it. And then maybe they're going to pass this to other downstream microservices. So I don't know. You don't talk a lot about how we model the tokens in order to best account to mitigate the risks associated with passing these tokens between these different parties. Even if they're first party, they're all our company, there could still be implications of how do we verify in a zero trust environment that that these aren't replayed tokens?
Indeed, I haven't talked about protocols almost at all during the entire series, because I just wanted to get the focus on the concepts, and different protocols that implement different concepts. And if you are talking about how to pass authentication information further downstream to further services, using OpenID Connect or O2 is usually related to a lot of pain, because those tokens, they can expire on the way between the services, etc., and usually it just doesn't work. And therefore, my recommendation would be, and this is also something I've tried to describe in the third content series, third blog post content-wise about identity propagation. Which options do we have there? So one of the options, it's just what you say. It's passing the external identity information, so authentication proof downstream, with some of the cons I just mentioned. And there are also other options. The least secure one is just extracting the ID, the identity information of the user or whatever entity which has been authenticated, and pass that downstream, which opens or which breaks least privilege principles. And if the intruder or attacker is within the network, he can or she can do everything she wants. And the two other options, which I at least know or aware about, is about token exchange, but that binds us to the protocol. So, and is actually not designed for that. It has been designed for third party, and it should be used on the third party side, the backend of the third party, if you like. And the other one, for which there's no protocol, is what networks and token propagation, or what I name protocol agnostic identity propagation. So I have chosen that name by intention, because if you're talking about tokens, people are directly thinking about OpenID Connect and L2. And this is not meant, because in security jargon, tokens can be everything which can be verified and which provide information about the identity or principles, if you like.
So X509 certificate could be a token, for example.
Also as opaque session. So just a session identifier. It is something also pretty often named as a token. And because of that, I decided to name it differently, just protocol agnostic identity propagation. And that basically means you terminate your external protocol at the edge, whatever the edge is. The edge could be also part of a sidecar in front of your service. It depends on the architectural constraints and the other contexts you are in during the development or design of your system, and you issue just a new token. In that case, it could be also a JOT by that offloading party, if you like. And that token is particular for that particular system scope. Sorry for the duplication. And you can pass it around because within your system, because it has been issued just on the edge, and it's for that purpose. And if the corresponding edge component allows that to do so, you can also enrich it with further information. And you are then completely independent of whatever is going on upstream. Be it something certificate-based, be it something OpenID Connect-based, be it SAML, CAS, whatever.
Well, so it's interesting. We did an episode on some engineers from Yahoo explained how they were using a token exchange to mint a new type of token called a transaction token, or as a tool likes to say, a TRAT.
It's kind of.
It reminds me of HTTPS. When we introduced TLS everywhere, it stopped a lot of types of attacks that happened only on HTTP without encryption. And I feel like TRATs, when you do a token exchange, you can actually prevent a lot of replay attacks by having the APIs not accept the, let's say, internet-facing token ever. And so I think people should look into that. I want to move on because we were just talking about sort of the authentication layer underpinning the authorization layer. So I want to move into the authorization because I think that's my new area of focus. But I think what I get out of this conversation is microservices are functionally autonomous units that may connect to other external systems or microservices. That the authentication layer, is allegedly solved through the use of issuing OAuth tokens or minting other JWTs or other cryptographically verifiable pieces of information. You have to architect it properly, but it's basically solved. Let's just say, you can figure out a trust model on how to trust the tokens. You can issue tokens. So we'll just assume, yeah, authentication's good now, even though that might not be quite as simple as that. But we're just going to say that so we can move on to authorization. So let me start in the authorization sector. And maybe you can just describe sort of you describe, I think, 3 of the patterns that were originally in OAuth, architectural patterns, but then you introduced a new pattern, which you call modern edge level authorization. So maybe you could just briefly overview, where were we when we started in OWASP, and sort of how did you help evolve that?
How to so in principle, the problem with what I named classic edge level authorization is there are social technical challenges, like I also have written in the blog posts, because those components are operated by other teams, and those components need to reflect the needs of the downstream APIs. We have a communication which must take place, and that kind of limits the abilities we have. So each time we have a change in our API, we have to contact the ops, for example, if those are the people responsible for that components, to let them tune something. This is a huge problem which is actually not yet solved in a classic world. So maybe the differentiation between classic and modern is the wrong one, because it's all about where we were and where we currently are. So which options do the systems out there give us nowadays? And this is also about context sharing. So because for authorization decisions, you need data, particularly from that particular microservice, or maybe from additional other services. So how to make that data available. And last but not least, in sense of the security-wise options, if we use that classic approach, I'm always showing embraces, that means downstream, everything is open, so you can do whatever you want. And the differentiation, and this is where the main differentiation to the modern part happens, is that I'm able, via, let's say, rules, define my own authorization contract, where I say, okay, dear edge component, when we do authorization, please use that policy, provide those attributes, or set these attributes to the call to the PDP.
Actually, I want to show a picture of a classic edge level authorization from your blog. Let me try and do this. I try not to share too much, because so people are just listening. Also, it's really small on your phone to see these diagrams.
Yeah.
But the diagram that I'm showing, actually, on the left side, we have a client who's making a request to probably an API, and between the microservice that runs your code, you have an edge proxy, and that proxy is looking at that HTTP request and enforcing security. So the proxy is the PEP.
Yeah.
And the proxy is relying on
moment.
tokens issued by an identity provider. And
Mike, may I interrupt you?
And you were
You're
raising
showing the wrong picture.
What's that? Sorry.
You're showing the wrong picture.
I'm showing the wrong picture.
It's
okay.
edge level authentication.
Let me take a look at the next kernel level. Okay.
So we're talking about authorization right now, and this picture is from authentication part.
Okay. Let me see. Normally I don't share. The picture kind of worked, though, in a way, at least for my narrative. So let me go to authorization. You're right, authorization. You're right. Wrong picture. Let's talk about how it's different then. Yeah, it didn't have the PDP in there. It was more abstract.
Yeah.
Okay, I got it now. Okay.
Yeah. As long as we are waiting, in principle, the information which is passed down to the microservice, it's just about what has been authorized. Yeah, it's not protected in any means. And that means if there's an intruder attacker in between in your network, it can do whatever he wants or she wants. And this is an issue. And in the modern case, we bring kind of an authorization contract. It's basically something which has a huge influence on your internal API.
Did I get it right now?
Yeah.
Okay. So we're saying the PEP. Yeah, I was showing it. Actually, it worked. Well, the diagram I showed kind of worked at a high level too. But instead of we're showing it more in terms of authorization jargon now. So on the left we have somebody making a request. There's the PEP evaluates the request and says, should I allow this request? It sends its decision to the PDP. And the PDP makes a decision and then it goes through. And you're saying is that once you get through this PEP, this part is unprotected. Is that your...
In principle, yes. In sense of what is allowed with that request. And usually, so I think
like zero trust to me, right? If this part is totally open, it sounds like it breaks the zero trust principle.
Yeah. That's also true. And another limitation here is you can only do decisions which result in yes or no answers. Yeah?
Right.
Are you allowed to
use deputy here? If you can trick the PEP, it might do something it's not supposed to do. So you're also susceptible to confuse deputy here.
In that case, the PEP will become part of the security components. Yeah, so basically on the same level as you have for the PDP or as you have for your authentication system. It's from the security point of view, it's an important piece, and it should be managed accordingly. Let's say it this way.
Right. But people love this pattern. This pattern has been around since I started in the business. I remember in 2003, I did a job for a large financial services company, and we built our own proxy using Apache, and we filtered based on SiteMinder information in sessions. So this pattern,
I did that as well in my past.
This pattern of putting a proxy in front of it has literally been around since the dawn of time, since the dawn of enforcement. And it's a good pattern, but I think, so your concern is that, okay, if this breaks and things have been known to break, this guy is still publishing an HTTP API on port 8000.
Imagine you have some other microservice in the same network and which is now compromised. Yeah? There's an RCE thing like something like that. And now we have an intruder in our network and he could open a reverse shell, for example, and then via that reverse shell, completely bypassing the PEP, we can then talk to that other microservice displayed here. And then everything is broken.
I'd like to also point out that the tokens might not actually be passed through. They might or might not be passed through. I guess they should still be there. If they came through the request, unless they got stripped out somewhere, they should still be here. But so what is your solution to this? Is the solution, let me try and stop sharing. Is the solution to actually embed a PDP in the end service too, so it also performs authorization and doesn't have to rely on the proxy in front of it?
It is all about the context, because the next two blog posts, I went pretty much into detail which let's say, decision dimensions influence the choice of the one of the other patterns. For example, how fresh the data should be for the decision. For example, how high the cardinality of the data is for the decision. All of that influence where you can put.
Before we go there, I'm just wondering about what the solution is to creating a zero trust problem where the application is not security aware and is trusting the enforcement, the proxy in front of it to do security for it, and now it's totally unaware of security. What do we do about that? Is the best practice for the application that to include some type of embedded policy decision point into its own code in case the PEP fails?
From my point of view, the best option you could do is you go into those what I meant with authorization contracts. So, and this is basically a combination of protocol agnostic identity propagation with some additional stuff, where you issue a token at the edge with information from the PDP, what has been done. It should be detailed, not just yes or not. And this is something you can then prove in your code. It can be as simple as that. That does not work always. So you might end up with combinations, but it's not about, okay, I don't trust my edge, I'm going to do everything by myself in addition. I've seen that as well, but this is less about security. This is more about complexity.
Okay.
From my point of view.
I have a problem when I hear people say the PDP should issue a token, because I see the PDP as something that makes a decision, logs that decision as the main purpose, and not as issuing tokens. If the PDP is issuing a token, then it's some type of identity provider. It's an identity provider of software or machine or person identity. So okay, but let's put that aside, and I want to say, then let's focus on the information, because this is the part where I have to say, everyone says to me when I talk to them about PDPs, how could it ever be that a service how could the PDP not be able to have dynamic access to databases and other APIs in order to get current data? And I've seen a lot of architectures for how to push data into the PDP's memory, or to give PDP connectivity to data that it needs for decision making and context. And so let's talk about that a little bit. It might be helpful if we use an actual example, because this authorization stuff gets too abstract. I have a music service called Pandora, and Pandora has implemented a feature where I am not allowed to listen on two devices. And so one would say that policy needs to check real-time information. And so there are different ways you can architect that type of a problem. But what are your thoughts about how the PDP should balance the need for, let's say, less reliance on failure? Like if I could do a real-time check, but that might fail, and speed, and the ability to do timely access. Like what would be some of the possibilities to architect a solution like that?
Yeah, there are many different options, but before answering to that, maybe small correction. I was not talking about letting the PDP issuing a token internally, but about the PEP, so PEP issuing a token. So at the edge. That's
the administration point. So you're saying that the administration point might issue a token?
Policy enforcement point. Policy enforcement point.
PEP might issue a token?
Yeah, based on the results from the PDP. And this would be a combination of protocol agnostic identity propagation with something else. And this is something I have described in the modern edge level authorization approach.
That would be innovative. I've never heard of a PEP issuing a token, because then it would have to be an issuer, have keys. And
Yeah.
you don't think about normally managing token key rotation or all the other stuff that goes on. We don't normally think about doing that in the PEP. The PEP's normally a consumer of the identity, not an issuer of identity. But this is why I actually think we need innovation. Like whatever we're doing right now is not working. That might be my question for the end, is we
Yeah, we
document what
can come to that question later on, yeah. But indeed, there are solutions out there, and not only the service I'm maintaining, small advertisement, Heimdall, but that's not about that. Back to your question. In principle, it again depends. Yeah, so we have three options, four options actually. Embedding the data into the PDP, which really makes sense. Only when the data never change or it is not expected to change at all. And if it changed, the freshness requirements are pretty low, let's say this way. So when the data change, how fast should be that change reflected in the decision? Then we have three other options. The one of the options is the classic one, when the PDP reached out or to calls to the other services, so policy enforcement or policy information points, if you like, and fetch the data. It basically then depends on the entire architecture, how much information is required for a particular policy and or particular policies. And what I've seen in the past is that it led to situations where ops had to drill a lot of holes in network settings, yeah, just to let that PDP, especially if it's embedded or as a sidecar in each and every service, communicate to other services. So that was an issue. And another issue or challenge which I often see is that, okay, if you do that, that basically means we have a direct dependency, and that contradicts the idea of microservices. So we would actually like to have that information being pushed to the PDP asynchronously. Yeah, and that brings us to what you name in the different episodes as Event Hub, basically. Yeah, so these are the two options, synchronous and asynchronous. And the last one is inline passing. So if the PEP, so policy enforcement point, is calling the PDP, it can also pass information down, so attributes down to the PDP. And the question is then here, okay, where does the policy enforcement point get that information? It again depends on the implementation of the or the capabilities of the policy enforcement point. So if it moves the responsibility from the PDP to resolve that information to the policy enforcement points. And here we have the same options. Either the policy enforcement point can call out directly to the other services, resulting most probably in the same issues like when PDP does that, and asynchronous, or embedded not or and that's all, and all the info, or the information is available from the request, and then we can use that approach differently. Again, at the end, it's all about combining different options we have, and there's no silver bullet for all of that. It depends pretty much on the context of the particular projects, on the requirements, and this is also why I try to describe those different I remember this.
Oops, we lost you. Could have been my internet. So that was great, and I think it's actually. I want to encourage people to read this and provide feedback. I didn't necessarily agree with everything in there, but if I never tell anybody about it, then it's not going to help. So I would encourage. I think that this type of exercise of listing the patterns, the architectural patterns for identity and authorization, is really useful. And the identity community, I think, just sort of looks at it, and I think we need to engage more with OWASP. I think the timing is right for that. By the way, a quick plug, we're proposing a FOSDEM dev room on application security. And I think in the past, FOSDEM has done security, which is very general in scope, and they've done IAM, which is sort of workforce oriented. And I think that these type of architectural patterns are really useful. And maybe at FOSDEM, I think it shows how much we need to think about application security specifically beyond just like general security or let's say traditional identity access management stuff. So great, Dimitri. Last thoughts before we break.
Just like you said, so I cannot say it better. Yeah, the entire series has been created to start the discussion. So from my point of view, it's not the end; it's just the beginning. So please take a look at the blog posts, make your thoughts, and let's talk about that. Let's define what is there, which patterns are there, and give the people out there the options in sense of how could they build their systems better, how could they build their systems in a sense that they are more secure. Yeah, because right now most of the options, at least I see, is okay, we have OpenID Connect and this is used for everything. It works, but in just maybe in 5% of the cases. In all other cases, this is not enough. And from my point of view, it is very, very important to spread out that knowledge, which is maybe in our small bubble, people who are working in security or IAM, and this should be made available to everybody out there, just to ensure what you are building is much more secure in the future than this is today. So I would like them to end with their appeal.
I think for microservices, authentication and authorization, it makes sense that OpenID Connect would only provide 5% of the solutions because OpenID Connect is primarily an identity layer for the web. And the web part is distinctly not even connected to the microservices part. So I'm actually sort of relieved to hear that OpenID Connect doesn't provide a big part of that solution. However, I do think OAuth is a critical part of the solution here. We can't reinvent what OAuth did. PKI is a part, SPIFFE is a part, and so but how we glue these things together is obviously less than clear right now. I have to say, I feel like we've done a terrible job in the OAuth identity community, helping people out understand how to use the like 30 OAuth RFCs that have been published. Most people conflate them all into one, but there's a lot out there. A lot of problems have been solved, and people aren't aware that those problems, that there's prior art on how to do this because we haven't told anyone, and then we don't comment on the patterns when people write them. So we'll try and do a better job, Dimitri.
Thank you.
At least I'll write it. I'll promote your pieces on ID Pro. ID Pro is a industry association. There's a Slack channel which is good, I think, for getting people's attention. At least those people addicted to Slack and chat. But this is great work. And when you say it took you 3 months, there's a lot of Sundays in there, I bet. So.
It's all about how to express it properly, so that what I want to express is also put into the words and not just some vague definitions.
And the artwork is really nice, I have to say. You made all those images.
It's drawable.
Yeah, so I like the artwork too. I always have trouble spending way too much time on those diagrams. So great job. Next episode, we're talking about AI again. Although I think we'll probably talk about AI once a month, probably until I stop doing this. And then the next host who takes over will probably talk about it. So but we have a guest from Ping Identity on, another guest. So we're diving again into some of the challenges around delegating authorization to agents, which is sort of similar to, in a way, to what we're talking about now at some level. But it should be good. That's on Tuesday, I think normal time, which is 1 p.m. Eastern time. And with that, I will say thank you, Dimitri, so much for your work. Thank you for joining us today. Thank you, audience, and we'll see you next time.
Yeah, thank you also from my side. Thank you, Mike, for inviting me, and also everybody here for listening. Thank you very much.